For years we've been on a mission, striving to connect the next billion users to the internet, to bridge the digital divide that separates communities and limits opportunities. We've explored every avenue, using everything from high-flying balloons, drifting in the stratosphere, to innovative drone technology soaring through the skies. But the traditional methods, like laying cables across vast oceans and scaling treacherous mountains, is proving to be incredibly expensive and painstakingly slow. This leaves billions offline, disconnected from the global network, simply because of where they happen to live. The digital divide is a stark reality, and geography, the very landscape of our planet, has inadvertently kept much of the world in the dark, limiting access to information and opportunity. But what if the solution, the key to unlocking global connectivity, isn't on the ground at all? What if we could bypass the limitations of terrestrial infrastructure and beam the internet directly down from space? This isn't some far-fetched science fiction dream anymore. It's rapidly becoming a reality, happening right now, as we speak. The next billion users won't be connected by traditional wires and cables snaking across continents, but by a network of sophisticated satellites orbiting high overhead, blanketing the globe with connectivity. This fundamentally flips the script on global connectivity, rewriting the rules of access and opportunity. High-speed internet is rapidly evolving into a fundamental utility, just like clean water or reliable electricity, becoming readily available virtually anywhere on the planet. Imagine a bright, eager student in rural Africa seamlessly accessing the very same educational resources as a student in the heart of New York City, or envision a dedicated doctor working in a remote clinic deep within the Amazon rainforest, consulting with a world-renowned specialist located in Tokyo, all in real time, thanks to instant communication. This is fundamentally about leveling the playing field for everyone, everywhere, and unlocking the vast reservoir of human potential that has been held back for far too long by a simple lack of access to the digital world. Space-based internet isn't just another new product or service on the market. It represents a completely new foundation upon which we can build the future of global society. The implications of this technology are truly massive, reaching every corner of our lives. From education and healthcare to business innovation and global communication, everything will be fundamentally transformed. The world is poised to become a lot smaller, more interconnected, and a whole lot more connected than ever before. The next billion users? They're coming online, not from the ground up but from high above. So, let's get right to it and break it down. What exactly satellite internet? Satellite internet is actually quite simple in concept. At its core, it's about leveraging the power of space to bring connectivity to your home or business. It starts with a dish on the ground, typically installed at your location, that talks directly to a satellite orbiting high above the Earth in space. That satellite then acts as a relay, receiving your data and sending it onward to the global internet infrastructure, connecting you to the vast network of information and services available online. Now you might be thinking, wait a minute, haven't we had satellite internet for years already? And you'd be right. Yes, but the old kind, the systems that relied on GEO satellites, were notoriously slow and laggy, often plagued with huge delays that made even basic tasks frustrating. But now, enter LEO satellites. This new generation utilizes thousands of small satellites strategically positioned in low Earth orbit, just a few hundred kilometers up, a fraction of the distance of their GEO predecessors. Because they're significantly closer, the latency, or the delay in data transmission, drops dramatically from a sluggish half a second to a lightning-fast 20 to 40 milliseconds, making it fast enough for seamless video calls and even online gaming, opening up a whole new world of possibilities. But the real innovation isn't just the lower orbit. It's the network itself, a dense constellation of interconnected satellites, ensuring there's always one overhead, ready to serve your connection needs. This allows for a seamless handoff of your connection as they orbit the Earth. So, as one satellite gracefully moves out of range, your dish instantly and imperceptibly connects to the next satellite in the constellation. It's a complex, precisely choreographed orbital dance, but for the end user, it's remarkably simple. It's as easy as plugging in a dish, pointing it toward the sky, and letting the technology do its magic. This revolutionary new architecture makes high-speed, low-latency internet access a real possibility virtually anywhere on Earth, regardless of location or infrastructure. There's no more waiting for expensive and time-consuming cables to be laid. All that's needed is a clear view of the sky, The result? Reliable, fast internet connectivity, even in the most remote and underserved places on the planet. It's not just about providing internet access in space, it's a fundamental revolution in how the entire world connects and communicates. The future of connectivity isn't buried underground, it's soaring overhead, readily available to anyone who needs it. And this future is arriving much faster and more powerfully than anyone could have reasonably expected. When it comes to LEO satellite internet, two names dominate: Starlink and Kuiper. Starlink from SpaceX is already live in dozens of countries with thousands of satellites in orbit. Their advantage? Total control. They build the rockets, the satellites, and run the network, launching at a pace no one else can match. Their goal: blanket the globe and become the go-to for anyone outside traditional internet coverage. Kuiper, Amazon's project, is playing catch-up but has deep pockets and global infrastructure. They're investing billions, leveraging Amazon Web Services for data and logistics, and planning over 3,000 satellites. Kuiper's focus: smaller, cheaper user terminals, and robust integration with Amazon's ecosystem. They're methodical, securing multiple launch partners to ensure steady deployment. The game is about scale, cost, and reach. Starlink has the head start, but Kuiper's resources and strategy make it a formidable challenger. Both are racing to connect the unconnected and reshape the internet as we know it. The competition is fierce, and that's good news for users everywhere. The real winner? Anyone who's ever struggled to get online. Let's get technical for a moment and delve into the intricate workings of this space-based internet system. These satellites aren't just simple relays bouncing signals around, they're sophisticated flying data centers, equipped with cutting-edge technology. Each satellite is packed with powerful processors to handle data, advanced phased array antennas for precise signal transmission, and even laser communication systems. The lasers enable satellites to communicate directly with each other at incredible speeds, creating a dynamic and adaptable mesh network that spans across space. This sophisticated network intelligently routes data efficiently, ensuring optimal performance even over vast oceans or sparsely populated remote regions. Imagine sending a signal from a ship sailing in the middle of the Pacific Ocean. That signal doesn't travel directly to a ground station. Instead, it bounces seamlessly between multiple satellites before finally being relayed down to a ground station located thousands of kilometers away. This internet highway in the sky, as we like to call it, dramatically slashes latency, providing near real-time responsiveness and significantly boosts overall reliability. On the ground, the user terminal is remarkably smart and user-friendly. Its sophisticated phased array antenna electronically tracks the orbiting satellites, making incredibly precise micro-adjustments hundreds of times per second to maintain a stable connection. You just plug it in, find a clear view of the sky, and let it do its thing. The terminal handles the rest, automatically aligning and optimizing the connection. Strategically located ground stations connect the satellite network seamlessly to the existing global internet infrastructure, fetching the data you request and sending it back up to space for delivery. The entire system relies on sophisticated software algorithms and the strategic placement of these ground stations around the world. The result is fast, reliable, and seamless internet access virtually anywhere you can see the sky above. It's truly a marvel of modern engineering, a complex system that remains largely invisible to the end user, yet is profoundly transformative for the entire world. The future of global connectivity is unfolding right above our heads, connecting the unconnected and changing the way we live, work, and interact. The impact of satellite internet goes way beyond streaming movies. In education, it means a rural school can access the world's knowledge, and students can learn skills for the digital age. In healthcare, remote clinics can consult with specialists in real time, send medical images instantly, and deliver better care through telemedicine. For families, it means clear video calls and staying connected across continents. Small businesses can reach global markets, artisans can sell directly to customers, and farmers can use real-time data to boost yields. It empowers people to participate in the global economy on their own terms. In disasters, portable terminals restore communication when everything else is down, helping first responders save lives. This technology is already proving its worth in crisis zones worldwide. Satellite internet isn't just about convenience, it's about opportunity, safety, and hope. It's a tool for progress, wherever you are. The world's knowledge, markets, and support are now just a signal away. That's a game changer for billions. Of course, there are real challenges. Cost is still a barrier. The hardware and monthly fees are steep for many, especially in developing regions. For true global impact, prices must drop and access must widen. Regulation is another hurdle. Every country has its own rules and companies need government approval to operate. Some governments worry about privacy, security, and competition with local telecoms. Then there's space itself. Thousands of satellites crowding low Earth orbit raise concerns about debris and collisions, what scientists call the Kessler syndrome. Companies are working on self-deorbiting satellites, but long-term sustainability is still debated. Astronomers worry about bright satellites interfering with telescopes and our view of the cosmos. Making satellites less reflective helps, but it's an ongoing challenge. Balancing connectivity, safety, and science is a work in progress. The promise is huge, but so are the responsibilities. The future depends on getting this right. Universal internet access is an economic catalyst. It's not just about tech jobs, it's about plugging entire communities into the global marketplace. Farmers can check prices, tour guides can reach travelers, and small businesses can thrive with digital tools. The gig economy and remote work become possible anywhere, letting people earn without leaving home. This could slow urban migration and revitalize rural areas. Studies show a direct link between internet access and economic growth. Satellite internet can unlock trillions in untapped potential, boosting productivity and innovation. It's an investment in human capital and opportunity. Connecting the world isn't just good policy, it's smart economics. So what's next? We're just getting started. The next frontier is mobility. Terminals on cars, boats, planes, even direct-to-smartphone connections. Imagine never losing signal, whether you're in a desert, jungle, or flying over the ocean. Companies are racing to make this a reality, starting with basic calls and text, then full data service. As networks grow and competition heats up, prices will fall and performance will soar. The next generations of satellites will be faster with more capacity and even lower latency. The internet will become a true global utility, always on, everywhere. This will power the Internet of Things, autonomous vehicles, and immersive digital worlds. The infrastructure we're building now is the foundation for the next era of technology. The future of the internet isn't just global, it's universal. The sky is no longer the limit. The next leap in connectivity is already underway. Space internet is more than a new way to get online, it's a leap that can reshape our world. For the first time, geography won't decide who gets access to opportunity, education, or connection. The walls between the connected and unconnected are coming down, one satellite at a time. The challenges are real, but the momentum is unstoppable. The real story is the human impact. Students, entrepreneurs, patients, and families, all empowered by access. This is how we level the playing field and unlock global potential. A truly universal internet is no longer a dream, it's becoming reality. And that will change everything.